Okay, everybody has been anxiously waiting for our speaker, and thank you for sitting through all of this chatter. Larry Gruenberger worked for Allis Chalmers for 22 years as, I have this written down, I might read it, as the chief engineer in charge of tests and evaluations and also of the proving grounds. He also worked at the proving grounds in Texas and Arizona and traveled around the world, basically. I know he talked about being in Africa, some of the tests. And he has a very interesting program.
When I get all done, you're going to conclude that I told you a few lies, a few facts. We had a little fun, and I explained a little bit of what went on at the proving grounds. As Cheryl said, I worked at the proving grounds for 22 years, with my last 7 years as the chief engineer in charge of the proving grounds. So before I get started, I want to thank one person. I should say I want to thank a husband and wife for getting me on this dog and pony show circuit, and that's Richard and Nancy Schleister. They put my name in a hat, and that's when I got on this particular circuit. The other thing I want to do is I want to give you 2 inside Allis Chalmers jokes. One of them is, you always hear John Deere talk about the long green line. Well, to us, the long green line was 2 of those 4-wheel drives pulling a 3-bottom plow. And the other one was when all these mergers took place, somebody said to me, Larry, International, when Case bought International, they had Case and International, and they said, well, what happens when, he said they heard they're going to buy Caterpillar, and now they'd have 2 dogs and a cat. I always like to start out my program with a story. You always have to have a story. And there was this one where the teacher was up in front of the class, and she said, tomorrow I want all of you to come back to class and tell me a real-life instance that has a moral. So the next day after lunch, she said, okay, now we need these stories. So first little Susie raises her hand and she says, well, we raise chickens and we have eggs. And we collect these eggs, and every Sunday we take them to town. And we put all these eggs in the back of this basket and put in the back of our truck, and we go to town. And on this one Sunday, the truck hit a bump, and a number of the eggs flew out and they got broke. The teacher said, well, what's the moral of the story? And she says, well, don't put all your eggs in one basket. So little Mary raises her hand and she says, I live on a farm and we raise chickens too. And every week we always put a dozen eggs in the incubator and they always hatch. But on this one particular time, only half of them hatched. And the teacher says, well, what's the moral of the story? And she says, don't count your chickens before they're hatched. So the next guy that raises his hand is little Johnny. You know it's coming, don't you? There's anybody here named John, is there? Anyway, little Johnny raises his hand and he says, my Uncle Ted was on a fighter plane in Vietnam. And the plane got hit by enemy fire. And so Uncle Ted had to bail out. And when he bailed out, he took a case of beer, a machine gun, and a machete. And while he was parachuting down, he drank the case of beer. When he hit the ground, he was surrounded by 100 Vietnamese. So he took the machine gun and he mowed down 70 of them, and he ran out of bullets. Got the machete out, he took care of another 20, and the blade broke off. So with his bare hands, he got the last 10. And the teacher says, well, what's the moral of the story? And he says, well, don't mess with my Uncle Ted when he's drinking. over here, this young man stopped me and he said, he's got to be dedicated. He's got to be dedicated to EC. Because he said when he was on his honeymoon, he stopped to see me at the proving grounds. And that always reminded me of the story I saw where a farmer always thinks a vacation, or tells his wife a vacation is when you get in a pickup truck and you go about 250 miles to pick up some parts or another tractor. Being that I was at the proving grounds, I'm going to tell you about some of the tests we ran. I'm going to go through this with slides, and then I have a film that you'll see how the tests actually went. Yeah. Okay, that's where it all started. That's the 1018 tractor from 1914. I know Richard has one, and how many more are there, Richard? Are there three? Three in existence?
There's about 13 if you count the ones in museums.
That many? Okay. Okay, anyway, that's where it all started. This is the Allis Chalmers complex as it was in West Allis. And this is 70th Street. That was the tractor plant at the end. And then this was tractor plant at one time too. But when they started building tractors in there, then this part of it became a machining center. That's where all the machines were. Most of that is tore down now. Part of it's a shopping center, parts of it is just bare ground. This is a shot at the proving grounds in Racine County. This was our test track. It was in the form of, it was an oval track, and then it also had a figure 8, so we could go round and round the track, but then we could change direction so we would be able to go the opposite way, so that we would test the differentials the same going both directions. We also had a winter proving grounds near San Antonio, Texas. It wasn't a whole lot, but it did the job. And we would use that through the months from January, February, March, and April. That particular picture I took in 1966 when I was down there running D21s and wing chisel plows. That shot was getting near our proving grounds near Sacaton, Arizona, which is south of Phoenix. And that we started in 1973. That's one of our employees admiring one of these cactus. They were all over at the proving grounds. Am I standing in your way? That particular cactus is probably about 150 years old. And they look real mean, but they sure get pretty flowers up at the top. This is what was running what's called a continuous heavy load test. And by continuous heavy load, what we would do is we put the tractor in 8 gear, and we would run so many hours around the track. And we had the speed set up so the speeds that you were going to run the most in the field, we would run the most test hours on. The lesser number of hour gears, we would run those less number of hours. And when we split it into 6 sections so that you wouldn't run 300 hours. If the test was going to be 300 hours in second gear, we'd run 50 hours in second gear, so many hours in third, so many hours in first. Then we would go back and repeat that again. So we would run all the gears, another segment, run all the gears, and that way we would get a better profile. This was another version of continuous heavy load. This one we were able to get more hours because this tractor was parked up on these large rolls. It went through a powertrain, and then there was an electronic load unit that we could adjust the load. And this would run unattended. It was all automated from everything from oil pressure, transmission oil, different temperatures. We even had a sensor if we got a flat tire, it would automatically shut down. Sometimes we had a little problem on continuous heavy load. That nugget came unglued. This was the test that everybody hated to run. This was called the pit test. There was a hole in the concrete track. It was about 15 inches deep, and the trick was to set the speed and the depth of the track. So when you came into the hole, you hit the bottom of the hole on the front side, so you really took a shock. And that was, we wanted to make sure that when you ran over those frozen plowed furrows in the fall, that it could take it. And you, when you went through this, you went through it about 5 miles an hour, so you got a pretty good jolt. I don't know if that's staged or not. Anyway, it proves that I used to work there.
After you staff hair.
Another shot at a pit test on a 160 tractor. This was the field version of pit testing. There's a little story behind this, because this happens to be a prototype 7000 series tractor, 7030 or 7050. And the story behind that was I worked all day on this tractor changing a hydraulic pump in a metal barn. This was down near San Antonio, by the way. And I worked all day. It was about 120 in this shed. The sweat was rolling down. I load the tractor up. I go out to the field, back it off the truck, ready to hook onto the chisel plow, and the front wheel broke off. You thought the pit test was bad. This ranked right up there. This was called the rough course test. And these pipes that you see, there was 3 of them at one angle, there was 3 of them straight, and then there was 3 of them at the opposite angle. And you ran over this at about 5 miles an hour. And the purpose of the rough course was to find out if all the fasteners were going to stay tight, if the headlights would continue to burn, those kind of things. If the battery would jiggle loose, what would come loose. This was the purpose of it. And we would also, like say, run mounted implements. For instance, say 4-bottom 2-way plow. And if we were checking hitches, we'd run over the rough course with that to simulate you bouncing over that frozen ground or rough ground. This was the rough course version of crawler tractors. And you can see this guy took a pretty good jolt. Now, there's a story behind this one, because the guy running that dozer, his name was Joe Capito. And Joe tested all the crawler tractors. And one of the main things that Joe tested on the crawler tractors was the winch. And he had a whole winch test that he went through to check those crawler tractors. And so the guy's trying to put 2 and 2 together, because at that time there was a song called Winchester Cathedral. Well, they had a song all put together that was Winchester Capito. This was the drawbar test. And this ranked about number 3 of what the guys didn't want to do, because on this test, you'd put the tractor in forward gear, and you'd pop out on the clutch, and the drawbar would swing to the side, and it would hit against the drawbar bail. Then you'd stop it, then you'd put it in reverse, and you'd back up and make sure the drawbar slammed against the other side of the bail. And it checked drawbars for bending. As you can see, there's a pretty good stack of front weights or rear wheel weights on the tongue of that thing. So we would go to SAE drawbar load and then run this test. And lo and behold, we found out that other things failed other than drawbars. We had wheel clamps, rear wheels, all kinds of things that we learned it was a good test for. This was a lift test, where you would lift that stack of weights up, and then you would just let them drop as fast as they would go. And you'd do that a number of times. This was what was called the pendulum test, testing cabs and roll bars. And what you would do is depending on the size of the tractor, would determine how far up that weight would swing. Bigger tractors, it would be up a whole lot further. Smaller tractors would be closer to the cab. And you had that white building, which was on wheels. And you could raise the building up, and you could roll it on tracks, and you could roll the building away from the tractor. The idea was that this test had to be done at 0 degrees Fahrenheit. So we would cool the building down, get everything at 0 degrees, raise the building up, roll the building away, make the smack, roll the building back, close the doors, cool it back down. In the meantime, we bring the crane around to the rear because you had to pass a side hit and you had to pass a rear hit. And you couldn't have any structural failures and you couldn't impinge on the operator. There was a certain operator zone that you had to maintain. Another test we did on the roll bar was the crush test, where you would put this bar across and you'd pull down with a certain weight to make sure that the structure wouldn't cave in. This particular tractor happens to be either a 60-60 or 60-80. Then we did actual rolls. We didn't particularly like to do too many of these because you also you had a lot of repair work when you got all done. And what we had when we were first going with this, just in the test phase, is we put a big structure around the radiator and so on, so we wouldn't smash all of those parts up. There was an actual side. There was an actual side roll. That was on a D21. There's a rear roll on a 7,000 cab, and you can see the structure that was around the radiator so that we wouldn't damage those parts. We also had to do test work as far as debris getting into the radiator. So what we did is, if all this stuff passes through, you pack the radiator and overheat. So what we did is we fed this straw into this snow blower while this tractor was running, and then we would run it for a certain period of time, and then we would take everything apart and we'd see how much material got through, and then determine what kind of changes we had to make to pass the test. This was, we ran a front end loader test, and we had a pile of gravel. It was usually about 50 yards of gravel, and then you'd take this pile of gravel and you'd pick it up and you'd move it about 200 feet and dump it, and you kept going until you got the whole pile from here to there, and then you'd take the whole pile back again, and you probably did that, depending on the size of the tractor, somewhere between 100 and 200 hours. Now, in this test, we were running a loader test, but we were also running front-wheel drive tractors, so we wanted to get in the mud to see how the mud would affect the seals and the front wheels and everything else. And if you're wondering what that tractor is, that's a 50-20. And that's I don't know if that's either 60-60 or 60-80, but that really got to be a soup hole. Now, this particular yard where we ran this test, this was our parking lot. And it had large overhead lights. The poles were like about 30 feet high, and we had 3 poles. And one morning I came to work and something looked different. I didn't know what it was, but something looked different. And after I surveyed the situation, one of the poles was missing. The guys were running a figure-8 test on a 75-80. In other words, we would run a real tight figure-8 because we were checking the CV joint on the drive lines. And the guy fell asleep and he ran over the light pole. That's what happened. This particular one was a 50-30 prototype. It's got the Japanese sheet metal on it, I think. And this is why you test, because what happened here was, as the guy was approaching the pile, the tractor broke in half through the bell housing. And when you pushed the clutch in, the tractor wouldn't stop, and it went right up the pile and landed on the ROPS frame. And as you can see, the bar under the front end loader kept the whole front of the tractor from falling down on top of the operator. So, we were really fortunate. This was testing an 8550 for the drive lines and articulation joint, and what we were doing is we would go through them. Maximum oscillation angles we could go through by having that hole, and then we made the mound so it would go all the way one direction and then would come out of the hole and go all the way the other direction. And we did that for probably about 200 hours, and that got to be kind of a tiresome test. This, you know, what I tried to do is stick in a few of the kind of close calls, if you want to call them that guys had. This one, we were running some kind of a gear test on this 50-40. By the way, Arlen, you asked about a 50-45. He left. Okay, when he comes back. This was a 50-40, and I told the guy, you have wheel weights hanging on the outside. Be careful. Well, he forgot. And he came around the corner, and the stack of wheel weights hit the first tow tractor here, broke the final drive housing off. The tractor went forward and stopped when it crashed into the rear wheel of another one of the tow tractors. The guy was lucky. He had about 4 or 5 bruised ribs, but that was it. This was one of our, what we call our digital acquisition vans. This van had a recording instrumentation inside of it. We could record 16 things that were happening on the tractor all at one time, pressure, speeds, etc., etc. Now, this kind of instrumentation has come a long way since this time, because we had some real deals with this thing, because there was an umbilical cord that ran from the tractor to the truck. The truck was heavy, the tractor had lots of traction. More than once we stretched the cable. And from this system we went to one that had an antenna on the truck, antenna on the tractor, and we could just park the truck at the end of the field. We could go up and down at will and collect the data, so that worked pretty neat. The same truck, we're collecting data on this lawn and garden tractor with the snow blower. This is what happens when your manager of engineering comes out and wants to run one of your test tractors. And they came walking back and they said, Larry, the tractor's out in the field. Can you go out and get it? Somebody tried to make a shortcut. They were in the field and they were going to cut across this place and didn't realize they were in this marsh. And so that's what we got. That's another picture of me with hair. This was down near San Antonio, Texas, and we were plowing, and we plowed up that huge rock that I'm standing by. It was a piece of sandstone. It was about 6 foot high and about 8 inches thick, and the plow caught a hold of it and just dragged it up. It was a monster. This is part of field test as well. Guy comes and says your tractor got stuck. Had about 3 wetbacks out there for about 5 hours trying to shovel it out. That's why you see the shovels and everything there. This is one instance. Probably the one I remember the best is some guy got a 8550 stuck. And on an 8550 4-wheel drive tractor, you have to reach up here and maybe even be on your tiptoes to pull the dipstick out. Well, this guy had this thing stuck so bad that I leaned down like this and I pulled the dipstick out. It took 2 winch trucks to pull that one out, and they were anchored by a crawler tractor. Now I got a few pictures in here of tractors that I know that you've never seen. This one I know you've never seen. This is a 7080 with the 555 Cummins engine in it. And that's why you got the 2 exhaust stacks, because it's got the V8 in it. And that was a slick running unit. That's the same engine that was in the 440 4-wheel drive tractor. And we ran a number of hours on this tractor out in Arizona. It did a nice job. The only thing about it was kind of peculiar to run this thing, because you had all these 3 posts in front of you. It was like you're running down the field with 3 fence posts in front of you. And just another shot to prove that was a Cummins. There's a 195. I don't think you've seen a 195. That's when they decided to drop the 190 numbers entirely, and the next model would be a 200. 5020. That's the way it came from Japan. Now somebody over there, I was sitting at the table and I knew they told me I was going to forget their name, and I knew I did. 5020. These things came to us. 5030. It's a 5020, though. I know it is. The other side says 5020. I'll bet you.
What's that one to the right?
Well, somebody asked me if we ever tested other people's colors too. So there's proof. Yeah, you know, in this business, you had to find out what the other guy was doing too. I mean, that's just the way it is. And I know that Case had a whole raft of different color tractors, and I know Deere had them because I've seen Deere's running in the field at their proving grounds in Laredo with different colors. So I know that. But anyway, this 5020, we got 5 of these things, and we started running through our test program. When we never did complete the hours that we were supposed to, but when we got all done, we had 5 of them parked against the fence. One of them was broken half, another one had the front wheels broke off, another one had some rear main housings were cracked. Every one of them there was a chunk broke off. And I thought to myself, well, yeah, this is just like that saw blade that I bought from the hardware store and took it home, and it said made in Japan, and first time I cut an old board with it, all I had was smoke. But well, made in Japan, what do you expect? The amazing thing was, we pointed all these problems out to the Japanese people when they came over. It wasn't like 5 months, and we had 5 more tractors, and we ran the whole test program and never had a problem. So they really responded to make this 5020 and 5030 a bulletproof tractor. This was a dream. These are, I think these are 190s, and these are just scales. You know, they're just toys, and they were fooling around with that concept. Take the front wheels off, put that frame on the bottom, and you wind up with a pair of articulated tractors. It never got beyond this concept stage. This was another thing that we did some work with, was trying to put duals on the front of front-wheel drive tractors, but that never worked very good either because you could hardly steer the tractor. You had so much rubber resistance on the pavement that it just was not the thing to do. I've never seen this thing. I just went through some slides and I happened to come upon this. I can't tell you anything other than it's a snowblower with a cab on it. I can't give any history on it. Never seen one produced. Don't know a thing about it. Couldn't find any paper, but there it is. Now I'm going to go in. I got a number of slides now showing you all the different kinds of paint schemes and sheet metal that was thought of to make the 7030 and 7050 tractors. And by the way, when the 7030 and 7050 came into production, we also had a 7010, but the 7010 was too expensive to build, and therefore it did not happen at that time. We got some rounded fenders, and this has got black decals. Another version with orange wheel weights, a black canopy, silver decals, silver front wheels. This is a quarter scale, by the way. This is a wood model, and just kind of wanted to show what the concept would be with a front wheel drive. Some little different styling. This time you got square fenders on the back, the black panel over the top of the hood. Another version with full side panels. And finally, ta-da, here's the production tractor. And this styling is because of a woman. had a vice president that on a weekend, he took his wife through the proving grounds, showing her what was all going on out there, and she told him that the styling that we were working on was ugly, and he ought to send it to a stylist to do it. So that's what we did. It went to a stylist, and that's what they came up with. And the removable side sheets, that really came from two guys down in Texas that really thought that that was something that we should do. They were pretty emphatic on it. They even wrote a letter up to Milwaukee saying that that's what they like to do. And that became a reality too. And I think that was a good deal, because if you had to have side panels where you had to take a lot of nuts and bolts off, you pay for all that labor at the dealership. This way, 2 clips and it's off. Now I know sometimes the clips come off and they fall under the tires too. I've seen that. And I've seen a guy walk into my office one day and say, "Hey Larry, what should I do with this?" And this was a side panel that had a whole row of cleat tracks all the way across it. I said, "Save that for the design engineer's retirement party." Here's where we're working with one of the new cabs. Now that's probably the one you saw on your honeymoon. I gotta rub that in.
That's the only thing I remember.
Is your wife here tonight? Oh.
Say she knew you were going to be here.
Back of that cab. It's an interesting tractor. There are only 4 in existence. They've never got to production. We received 4. They were in the wooden crates. When Deutz bought Allis Chalmers, I was told to sell the 4 tractors. So if you're looking for a collector tractor, that would be one, because I know there are only 4. I know where there's 2 of them, but I don't know where the other 2 are. That's a 50/30 front-wheel drive. This was a kind of a unique piece of equipment. It was called a hydrostatic tool carrier. And what it was a piece of equipment that it had a 426 engine on it, a large hydraulic pump, motors on each of those wheels in the front. And the gimmick was that you could put a cultivator underneath the middle of it, you could put a planter under. It was going to be one of these universal type pieces of equipment. There only was one built, and that's it. And when Deutz bought Allis Chalmers, I know that one hit the scrap box. That's a shot of the front of it. In this particular instance, somebody had already taken the engine off. But it worked pretty slick. The front wheels drove hydraulically, and the back wheels were castered. And you had a lot of clearance for cultivating and so on. It was a good concept. This is one that you've probably never seen, but I'm sure some of you have heard about it. And if you read Norm's book, you probably saw it in there. When Deutz bought Allis Chalmers, this tractor had been completely tested and was ready to go into production. This was going to be called the 8095. It was 195 horsepower. It had a 10-liter Komatsu engine in it. It had a 6-speed transmission with a 2-speed power director and a 3-speed range transmission. And the reason, if you see that little extra, you see the side sheet with the Allis Chalmers on it, and you see like another little panel, that had to be added because of the length of the engine. And this tractor was going to be front-wheel drive only. This is a shot from Nebraska, at the University of Nebraska tractor test. And that was another one of our functions at the proving grounds, is we prepared the tractors for a Nebraska test. Our engine lab, they did the engine, put the engine in a tractor, and then it was up to us to run. We ran break-in in every gear. We probably put about a little over 100 hours on a tractor before it went to Nebraska by the time we ran the break-in of all the gears and In other words, we loosened the tractor up, made sure there were no oil leaks and all, all those kinds of things. And this was kind of neat to go to Nebraska, because when you think about it, when you got to take this tractor to Nebraska, there were like 1 or 2 people that were there that represented your company, and what you really represented was the efforts of all the thousands of people back home. The engineer that designed it, the test guys that tested it, the people that manufactured it, the whole gamut. You represented all those people. This is kind of the lineup at that time, starting out with a 50-20 and going all the way back to an 85-50. This happened to be taken at the Loretta Lynn Ranch down in Hurricanes Mills, Tennessee. And we worked with Loretta Lynn's ranch. They had all of our equipment there to do their farming. And as a result, we could use the ranch whenever we wanted to have dealer meetings. We could bring all our dealers down there and use the facilities and work on his ground and so on and so forth. Just a side view of the same lineup. This is the Terra Tiger. I don't know, has anybody seen a Terra Tiger? You got some. Anybody looking for a Terra Tiger?
No.
I know where there are 2 prototype Terra Tigers that the guy wants to get rid of. That's why I asked the question. But anyway, this thing here, this was a kind of a neat test project, because we had a course set up where you went over some hills and you went through some water and you went over some marshy area and the whole gamut. And everybody got to run an hour. That was mandatory. When your hour came up, you had to run that hour over this course. And I remember one time this guy that got stuck in the mud, this manager of engineering came out with a couple of other white shirt guys, and him and another guy got in this thing, and they were showing the rest of the bunch how you run this and how maneuverable it is and all that kind of stuff. And they came zooming up to where the crowd was, and they spun a U-turn and they flipped it over, and the cart was right on top of them, and they dumped themselves in the mud. Now, I know Jerry Oxborough from the Independence plant, and he heard me, somehow through Doug, I think he found out that I was going to be here, and he sent me this slide and another slide. And this one happens to be the old one, the 9400 tractor. This has the high clearance final drives on for the cane country. These final drives happen to be exactly the same final drives that were on like the 8010, 8030, 8070, all 8050, all those high clearance tractors. They dug out the old molds and sort of they made new ones from it, and then they come up with this tractor. And that's the new version. That's the, he said that's the 9700 tractor. I think they need about 26 inches of clearance for the sugarcane area, because of the way sugarcane grows. It grows up on top of the beds, and the wheels of the tractor run down in the bottom of the bed, so you need the extra clearance to work the sugarcane. Okay, with that, now I've shown you in still pictures how we've done these tests. Now I have if you bear with me for a couple of minutes, I got a video of how this stuff goes when you actually run it.
Welcome to the Allis Proving Ground. Yes, I said proving ground, because we're here to prove the technological leadership of our new family tractor. Most of you are driving orange tractors today, and that's exactly the reason we invited you to ask questions, hard questions about how your tractor compares to ours. Feature for feature.
Can you hear it in the back?
Turn it up. Open your eyes to the rising power in farming and and you be the final judge of Allis Chalmers' leadership. Let's start at where all this leadership began, with the earliest tractor. And here it is, the Allis Chalmers Model 1018. Introduced in 1914, this was a three-wheel tractor weighing 4,800 pounds. Its two-cylinder engine used gas and stocking and kerosene for running. By 1920, the four-wheel Allis Chalmers appeared, and these early successes led to establishment of the Allis Chalmers Tractor Division. The 1930s marked a breakthrough that was to set the industry pace ever since. The first rubber-tired tractors. That's Barney Oldfield driving this rubber-tired Model U at an official speed of 64.38 miles per hour. And while Allis Chalmers had introduced diesel-powered crawler tractors in California, the tractors that won the hearts of farming families everywhere were these. The Model WC, followed by the Model B, the best all-around tractor for many years, and the Model C. The post-war years saw many engineering innovations appear. Speed to fit the job. Two and four-row quick-hitch cultivators. And hydraulic lifts. All brought new time-saving convenience to family farming operations. By the 1950s, such features as two-clutch power control, complete hydraulic systems, automatic traction booster, power shift wheels, and snap coupler hitches were proving Allis Chalmers' leadership in engineering technology. The D series of tractors appeared with new low-line, high-crop design, new center-ride comfort seats, and roll-shift front axles. And in 1961 came another breakthrough. The first factory-installed turbocharged diesel, the Model D19. Allis Chalmers' reputation was made in smaller tractors, a trend that continued in the 1960s, where orange tractors like these models could be found on virtually any farm in every part of the nation. Then it happened. Allis Chalmers made a bold new commitment to the American farmer. A decision had been made to become the new leader in tractor styling and power. The rising power in farming was born. This exciting commitment meant a capital investment in new equipment, turning to modern computerized tooling, expanding engineering research development, making a major investment in our dealer organization, and creating Total Quality Assurance. Total Quality Assurance is a complex program of management-directed quality control, which places responsibility for quality on every individual in the production chain, from product conception to field service. Simply stated, TQA means doing the job right the first time. The first results of this major investment in so many areas started rolling off the production line in 1973. The 70-30s and the 70-50s. Sales increases became measurable almost overnight. Owners of red, green, and the other color tractors took notice. The closer they looked, the better they liked orange. And that brings us to today, the new family of Allis Chalmers tractors. The new standard that others in the industry now must meet. Let me introduce them to you in this way. In this one rodeo stall, we corralled 135 horses. 160 in this one. 180 horses in here. And we're going to turn them all loose right now. And convenience. Reliability. Dealers you can count on. Leaders in the field. And here, on this proving ground today, we want to prove it to you.
With the rising power in farming, open your eyes.
Almost everyone who has ever driven a tractor is interested in how they're tested And some of you may even have the idea that many of them never were. We can assure you that at Allis Chalmers, prototype tractors are rigorously tested, even tortured, to prove that every detail of the design performs as it should and meets high standards of long life. For instance, tractor powertrains are subjected to two important testing procedures: continuous heavy load and breakdown. Continuous heavy load testing is accomplished by weighting the tractor to 170 pounds per PTO horsepower and loading the tractor until it is operating at 100% of engine horsepower. The load consists of old tractors which have been converted by adding a hitch frame, weighting them down with concrete and iron, and installing controls in the manifold so the engines become air compressors. Tractors must withstand hundreds of hours of continuous operation, and each of these hours is equivalent to 3 hours of normal field operation, since the tractor is operating at 100% load, while normal field work averages about 65% load. Continuous heavy load testing can also be accomplished on chassis dynamometers. Dynamometers are adjusted to absorb 100% of engine horsepower, and tractors are operated continuously. Automatic controls sense any malfunction and stop the tractor if trouble should arise. A computer monitors the test at all times, so the tests continue around the clock without tying up manpower. Powertrain breakdown testing can also be done in two ways. On the track, the tractor is loaded in the same manner as for continuous heavy load testing, but instead of grinding along at a steady pace, the operator disengages the clutch and allows the whole rig to roll to a stop. He then removes his foot from the pedal in a sidewise motion that allows the clutch to snap into engagement. Naturally, the entire powertrain is subjected to extreme shock loads. Tires spin and grind away pounds of rubber. And finally, the train reaches operating speed again, at which time the operator starts the whole tormenting procedure all over. This happens about every 30 seconds for hundreds of hours. As high stress points are located, they can be corrected until all are eliminated and the powertrain passes test criteria. You can imagine just how enthusiastic tractor operators would be about this test, especially during Wisconsin winters before cabs became popular. In order to accelerate powertrain testing, Allis Chalmers test engineers designed a special device to automate the track test. The tractor is backed onto the water-cooled skid pads, and the three-point hitch is connected to stationary anchors. Loaded to test weight, and with the engine operating at full power, the clutch is snapped into engagement by the automated controls. Tires spin as the powertrain is shock-loaded. The screech is deafening as worn-off rubber piles up behind the tires, and the tremendous power is converted into heat to be carried away by the water cooling system in the skid pads. Hydraulic jacks lift the tractor slightly as the clutch is automatically disengaged and the wheels coast to a stop. The tractor then lowers back to the skid, and the cycle starts again. Hour after hour, day after day, this cycle repeats every 30 seconds. Since the only manpower required is for routine maintenance, test hours accumulate up to 4 times as rapidly. Bad weather, which would disrupt track testing, no longer interferes with the test program. When you drop the front wheel of your new Allis Chalmers tractor into a chuck hole for the first time, it really isn't the first time. During development, prototypes made dozens of trips like this. If there's any test that operators like less than this, it is probably the rough course, which can deliver severe shock loads to the tractor, its three-point hitch, mounted implements, and of course, the driver himself. Automation would really be welcome here, wouldn't it? The three-point hitch on your tractor will be subjected to a great deal of abuse, even in normal operation. Overloads, side thrusts, and twists will be a part of its daily fare, so you can bet it will get its share of torture, both in the laboratory and out on the track. The drawbar will get tested very much the same as it will when you have a heavy implement hung up in deep mud. This goes on until something has to give. Each cab, or protective frame, is subjected to 2 tests, the pendulum and actual rollover. The larger the tractor, the greater the prescribed arc of travel for the pendulum, and the greater the impact. The deflection of various members of the cab is carefully measured to ascertain whether they would contact the head of the operator who is properly belted in the seat. The idea of turning a tractor over sends chills all over, but it's nice to know your cab has been thoroughly tested to meet the tough standards. The tractor must be rolled both sideways and over backwards. In addition to crush resistance, other factors such as control of flammable or noxious liquids are monitored. Here is a scene that we hope none of you will ever witness in person. But if you do, we certainly want it observed from the inside of a cab that has been tested and meets the industry standards. We'd like to keep all our present customers and have some new ones too.
When we decided to bring a new four-wheel drive into our rising power family, we wanted to offer all of the proven features of our big new two-wheel drive tractors. Like our 20-speed power director transmission that turned this mighty 222 engine horsepower into an acre-eating workhorse. It had to have an independent PTO that turns out a hefty 185 estimated PTO horsepower. And easy maintenance features like our well-known snap-off side sheets, swing-out batteries, quick-check sight glasses, a very quiet acoustic cab. Then we decided to make this new four-wheel drive so flexible that it can be used in everything from flatland wheat to hillside to row crops. And bit by bit, part by part, this new tractor became the four-wheel drive we always knew you wanted. And now, it's ready for you to have. Consider the sheltered life you'll lead inside the new 7580's acoustic cab. The quiet, the comfort, padded, adjustable seat, convenient controls, power steering with a multi-position steering wheel, power brakes, standard heater and pressurizer, options like air conditioning, even a stereo 8-track if you wish. You ride in a controlled, conditioned world surrounded by 41 square feet of tinted tempered glass.
You want to cover a lot of ground. Well, there's a way to do it with a new kind of sound. So look to the new world of quiet in an orange sky.
Whoever said you can't use four-wheel drive in a row crop application? With 18.438 tires, the 7580's wheel treads adjust from 62 to 120 inches. Add to that our optional 3-point hitch, and this new four-wheel drive tiptoes through the roads. With a mounted or semi-mounted implement, it's very unlikely you'll step on a road. And watch it move around this corner. The 7580's full 40-degree articulation lets you cut a tight 17-foot turn radius. Of course, we wouldn't offer a new four-wheel drive that didn't have one of the toughest powertrains around. From its multi-disc wet clutch up front, on through the power director transmission and planetary final drives to the huge rear axles, this new 7580 tractor is muscle in motion. With 18.438 tires, the power director transmission gives you 8 speed selections from 2.5 to 6.5 miles per hour for your field work, a slow speed for PTO operation, 4 reverse speeds, and road speeds up to 18.9 miles per hour to get you home quickly. Not to mention our shift on the go and 2-speed ranges. Notice how the 7580 simply snakes over bumps, ridges, how it follows those dips. That center oscillation, a full 25 degrees of center oscillation. It takes a rugged machine to handle this kind of big acre farming. That's why we mounted the 7580's axles both vertically and horizontally to its tough half-inch thick steel plate frame. This not only gives the 7580 greater overall undercarriage strength and rigidity, it gives you a more comfortable ride. Anyone can offer you a hydraulic system, but the 7580 gives you a hydraulic system with a total 74.9 gallons per minute. And something no one else offers, our exclusive closed center, load-sensitive circuit. A load system that doesn't waste horsepower maintaining either a constant high volume or constant high pressure. It keeps the horsepower at the drawbar and PTO where you need it most. The new 7580 comes equipped with 3 remote outlets. One more can be added if needed. To get you through those real tough spots, the 7580 offers even more than 4-wheel drive full power. A draft-sensitive 3-point hitch senses loads through the lower links to maintain a more uniform depth. And consider, this new 7580 offers a multitude of tire options. Means you can get all the footing you need for just about any job you tackle, even for muck-stuck rice conditions.
Rising power means better tractor. Allis Chalmers means a sure quiet ride.
Look at how the 7580's shift-on-the-go transmission makes molehills out of big hills. Of course, its big 426 cubic inch Model 3750 Mark II engine helps. This tough turbocharged diesel really puts out, gives you the kind of performance you need for big acreage, get a lot done days. But there came one surprise. For when we ran it through our tests, we found, even with its big new power, the 7580 is very fuel efficient. And think of the extra acres you can cover with the 7580's huge 170-gallon fuel tank. The new 7580 tractor from Allis Chalmers. It's a new dimension in center-articulated crop versatility. And it's waiting, bright, shiny, and powerful, at your Allis Chalmers dealer.
Come on, join us, we're the people who care. Allis Chalmers, helping farmers everywhere. They call us the rising power and song.
This part of it doesn't belong on there. This doesn't have sound, but this is the pit test. This is an actual one. Sometimes they don't make it. And there'll be another run. Well, this is the pendulum test. That pendulum weighs 4,410 pounds. And as I said before, the angle that you pull it back depends on the horsepower of the tractor. The crane operator was really good because he'd make sure that it only hit once, and then he would raise the weight so it wouldn't hit a second time. How that got in there, I don't know, but that was my boss.
Probably a good thing you didn't have sound.
We don't know what was supposed to be on here, but I didn't have a chance to really edit this, so what you see is what you get. Okay, this is looking at a front axle before a pit test. Okay, can we have the lights? Poked a hole in the oil pan and did some other damage as well. And this was, the pit test was the test that I hated to run worse than any other test because it always seemed like there was going to be a problem. And it was a tough test to pass. But when it did pass, you knew you had a good front axle. Cheryl asked me if anybody's got any questions, and she says I'm short, so I better stand up here. Is that what you said, Cheryl? Yes, sir.
How many times did that happen on that test, on that front axle test? How many times do you have to hit that hole before you consider it passed?
25 times per side. That's 25 pretty good licks.
Larry, where those new tractors were showing, the new 7000 series, what were those white buildings behind there? Where was that at? It was on the grass there, the new 7000 series?
Oh, the metal buildings that you saw in the background, that was the actual proving grounds in Racine County, Wisconsin.
Okay.
That building, that complex consisted of one large building where we did well, let me explain what the proving grounds was. It consisted of a machine shop, a sheet metal shop, a welding shop, sheet metal and heavy metal bending. So we could make a lot of parts ourselves out there. Once we had the parts made, we would move them into the main assembly area, which was approximately 100 feet by 300 feet. Had two 15-ton cranes and a number of 10-ton cranes in there. And that's where we would assemble the tractors so that we could run the tests there at the proving grounds. And at the proving grounds, all the tests were total unit tests. I mean, we didn't run components. We ran a whole machine. That's what we tested. In addition to the shop area, the assembly area, we also had another building that was a storage building at the time, at the tail end. But prior to that, it was a design building, because at one time, Allis Chalmers moved all the design engineering to West Allis. In other words, all the design people that were at LaPorte that worked on the harvesting equipment, all the people at Independence that were on the combine and the tractor people, and then also all the design people from La Crosse that worked on the plows. All that engineering was moved to Racine County, and so that building housed all those engineers. Then we had the dyno building where you saw that tractor running on the rolls. We had that. It had a roof on it, but it was wide open because we didn't want to build up of heat. Then we had another building where you saw that tractor running on the skid pads. And I should have explained that a little bit to you. That was called a breakdown test. Now you saw the one on the track where you'd load the tractor to whatever the tractor could pull at rated speed. And then what you would do is you'd pop the clutch. And you'd get that shock, and then the tractor would slowly pick up load until it got up to speed when the engine was running at rated speed. And you pop the clutch every 30 seconds for whatever hours the test was. And some of those tests were 500 hours, some were 250, and some were 1,000. Now when you saw that one that was inside the building, they were talking about the skid plates. Okay, that was pretty unique because we did a lot of work on that to get that to work. When you would pop the clutch, those tires would spin on that. The tires would spin on that sheet metal, and they would get greasy. The tires would get greasy, and you wouldn't get the load. So what we did is we really had two plates, one above the other, with a metal channel work between the two plates, and that was all welded together. So then, and we had water flowing through those plates to take the heat away from the spinning tires. So the way the test worked is you had the rear tires sitting down on the plate, you popped the clutch, which produced the shock, and when the engine was loaded down to a specified RPM, then those jacks in the back would raise the back of the tractor up while the tires were spinning on the plate and then would be spinning in the air. Then the clutch was automatically pushed in, the tractor would be lowered back down on the plates, and you'd go through the cycle again. That's the way it was run on the inside of the building. The nice part, like the movie said, we could really pile up cycles because we didn't have to worry about the weather like we had to do up on the track. Anytime it rained or snowed or whatever, you couldn't run that test on the track because you couldn't get the traction. Okay, does that answer the question? Any other question?
How come they didn't have so many grind gears for 10 years in the 15 to 14 series to find out third gear wasn't very good in it?
I can't answer your question because I probably wasn't even a gleam in my daddy's eye back then.
They sure had the problem with transmissions there that after the years showed up in them.
Well, you know, as you look at how this testing progressed, and the way we did things, there was really some improvements that were done on our procedures. If you look back at the early testing, it wasn't as controlled. I mean, here we ran on the track, we ran knowing loads, we knew what was going on. Back in the early testing, they ran in muddy conditions, spinning tires and pulling loads and so on. But when we started out, this would be in the early 60s, we really came up with a whole set of test procedures. I mean, we had a book that was that thick, and it told you exactly when you run this test, how you run it, how you load the tractor, the whole thing. And I think it helped make a better product. Anybody else?
What about those test tractors? How often did they break down? What years did you post in, and what were they, and how did you make the engines load?
Okay, the tow, this gentleman asked about the tow tractors. First of all, let me say there is one of those tow tractors still in existence, and Richard, where do you have the tractor, Richard?
My son-in-law at Decoy.
Okay.
Turn that other microphone off.
Okay, yeah, there's one existence, and Richard has that particular tow tractor, so there's one around. Now, how was it made? When you saw the whole string of tow tractors, you didn't have one hitch to the other one, so that like the first tractor, all the load was being pulled through the powertrain. The load was pulled through the hitches, and the tractors just sat on top of these hitch frames. And well, they'd last maybe 2,000 hours or something like that, and then we'd have to go in and put new rings, and you'd have to overhaul it just like you overhaul a normal engine. And you had the cooling system on it because you were putting that power through in the reverse direction, so you had to have a radiator and all the cooling system and a water pump. And I don't know if you're familiar with powertrains or not, but there's what's called spline lock. So when you load it in a certain direction so it doesn't jump out of gear, well, in these tow tractors, we had to grind the spline lock in the opposite direction because we were loading it the other way. And as far as what speed do you run them in, you wanted to turn the engine at the same speed that the engine would turn normally in a tractor. And that was the biggest thing we had to watch, so we didn't overspeed those tow tractors, because you'd get somebody up on a track and he's running, say, in 5th gear, and he's got a tow tractor in 1st gear. He's going to run that tow tractor at about 6,000 RPM, and we can pick all the parts up in a bushel basket. So you had to match the gear of the tow tractor to the gear that the pulling tractor was moving at. And we got pretty good life out of them. What you saw in the movie was, I think you saw mostly D19s, and I think there was a D21. And towards the end of like 1985, when Allis Chalmers no longer existed, at that time we were already making tow tractors out of 7000 series, and we had a couple of 70-30 tow tractors at that time and a couple of 70-50 tow tractors as well. So we were trying to upgrade the fleet, but then we always had to keep some of the D19s because the little tractors couldn't pull those big ones, or the drawbar load would be too heavy. And that was another thing, when we hooked the tow tractor on, we always had to take into consideration the drawbar load. So if the tongue weight was too heavy on the tow tractor, what we would do is we'd put weights on the back of the tow tractor to take some of that weight off the tongue at the front, so we didn't overload the tractor and really have it set at too many pounds per horsepower. Yes, sir.
What had happened to all the equipment then, like the test tractors and stuff? Would they just be scrapped out or fixed up?
A test tractor would always be scrapped. And the reason being is that there's always experimental parts in it. And if I sold you one of those tow tractors and you took second gear out and you go to Doug's store and you say, I want one like this, Doug is going to look at you with a question mark and say, where in the world did you get this from? And to avoid all of that, that's what was done. And we either scrapped them or we made these tow tractors out of them. We never sold an experimental tractor. Anybody else? Oh, I'm sorry.
Was all the holdings all liquidated then when they closed operations down?
At the test center?
Everything, I mean, all the manufacturing and everything was all.
Yeah, all the manufacturing stuff was sold at auction. And out at the proving grounds, I personally sold everything out at the proving grounds. I sold we had a number of tractors used for tests that were production tractors. Those all got sold as used tractors. All the trucks got sold. All the machines in the machine shop got sold. The 550 or whatever we had rear tires, they all got sold. Anything that was a production part, we sold. Anything that wasn't, we threw in the scrap box. So when we got all done, the proving grounds was bare, and inside the building was 4 bare walls.
No prototypes hidden away someplace? No prototypes hidden away someplace?
No, sir. Well,
Why not?
well, there's a couple that are pretty close. I think there's a crawler and there's a 185 gas, right, Richard? Yeah.
There's 4 crawlers
Yeah, there was some other crawlers too.
and the one you called it a 17 series high.
Yeah, that was that 185 gas.
And then there's the 160. They were sitting out before.
Yeah, I don't know what happened to those.
I've got those.
There was a 160 gas. Did you get that one?
Yeah.
You got that one.
Kind enough to sell it.
So there are a couple of them, and they'd be the ones that Richard got, because I don't know of anybody else that got an experimental tractor.
Are you aware of where AGCO is doing their testing now? Is that done down in Independence, or do you have any idea?
I think they're doing it at Coldwater.
Coldwater?
Yeah, because as a matter of fact, I know they're doing it at Coldwater, because like I said, I know the guy that was running the pit test, Scott Koss, and I know he's their manager of engineering. And then Scott worked for me, and then there was another guy that worked for me, Jim Rowerdink, and I know Jim is down there, and he's the test guy. So I know they're doing testing at Coldwater. Anybody else? Yes, sir.
Now you showed most of the tractors. Did you test all implements and everything at the proving grounds then, like plows and everything else, or?
When we were all one happy family, when all the engineering was at one location, then we tested everything. But then that didn't seem to work very good, so then the people from Independence went back to Independence, and the people from LaPorte went back to LaPorte. And then we were running only tractors again. But we would get implements from, say, LaPorte. If we needed to pull a chisel plow or a disc or a plow, they would maybe send up a test implement, and we'd run a test implement with a test tractor. But that didn't happen too often, because they started running their own tests, and they wanted to run it a certain way. And we wanted to put production implements on because we didn't want to fool around with experimental implements and lose all our test time of not getting hours on tractors. So it didn't work too well. But when we went south, like say for instance, when we went to Texas for the winter, well then they gave us their best shot, and we had our best shot with a tractor, and that worked pretty good because the main thing when we went down there was 24-hour-a-day operation, 7 days a week.